Hi, I'm Patty Simpson with Simpson Math. And in this series of videos, we are talking about parent functions. In this particular video, we're going to deal with the parent function of the absolute value function. So remember that absolute value functions are in some form such as this, or maybe in function notation they look like this, where our x value just is inside this absolute value symbol. So in each case, our x value is inside the absolute value symbol. And the simplest form of that, or our parent function for the absolute value function, looks like this, where we just have y equal to the absolute value of x. And mathematically, we define the absolute value function, our parent function, where we have our y value equal to the absolute value of x, as a piecewise function, where when x is greater than or equal to 0, in other words, when x is positive, our output is just the x value. When we input a negative value in for x, then we get out, our output is a negative of that negative value when x is less than 0. And in layman's terms, basically, this just means that the absolute value is just the distance from 0. That's really what we're dealing with. We're just looking at how far away is our input from 0. So there's our parent function of our absolute value function. And we're going to graph that function. So let's look again at that function. And before we graph it, let's think about our x values. Is there a number that if we put it in, a real number, that if we put it in for x, that we don't get out a real number for y? So let's try first, say 0. If I put 0 in for x, in other words, if I have the absolute value of 0, how far away is 0 from 0?
0 units from 0.
So that's a real number. So our y would be then 0. What about if I put in, say, a negative number, like -2? So if my x equals -2, then how far away is -2 from 0?
Well, it's 2 units to the left, usually.
Good, so it's 2 units. So if I put in -2 for x, I get out 2 for y. What about like a number like the square root of 2? How far away is the square root of 2 from 0?
Well, it's square root of 2 units away, which is approximately 1.4.
It's about 1.4-ish units away there. So when I put in the square root of 2, I get out square root of 2. All of these are real numbers. So when I put in a real number for x, I get out a real number for y. And I can do that for all of my x values, and I'm going to get out real values. So we say our domain for these absolute values, or our x values, can be all real numbers. And in set builder notation, we write that like this, where it says x such that x is an element of the real numbers. We're going to do later a whole lecture on domain and range, where I show you these different notations. This is set builder notation. To say the same thing in interval notation, we go from -infinity to +infinity. In other words, my x values can be anything in between -infinity and +infinity. So since that's true, I can pick any numbers I want to plug in for x. I'm going to use these 5 values, -2, -1, 0, 1, and 2. And I'm going to plug those in for x, or substitute them in for x, and find out what my output is. So if I put in -2, how far away is -2 from 0?
2 units.
2 units. If I put in -1, how far away is -1?
1 unit.
1 unit. If I put in 0?
0.
If I do, just to show you what I'm doing, I'm putting in 1 as my input, and out comes, well, how far away is 1 from 0?
1.
1 unit. So my y then, this y unit is equal to 1. And if I put in 2?
2.
2. So now I can graph those 5 points that are on this parent function of this absolute value. So there's a point at -2, 2. There's a point at -1, 1. There's a point at 0, 0. Notice that this 0, 0 is on my x-axis, so we say it's the x-intercept. And it's also on the y-axis, so we say it is the y-intercept. Then there's a point at 1, 1, and also at 2, 2. So the parent function of my absolute value function looks like this. And because my x values can be anything from -infinity to +infinity, there are points even in between here, you know, at -0.5, or 1.5 and 1.5. And it goes on and forever and ever in each direction, so I put arrows there on the end of my function. And I could label all the points, especially the important ones, and say, hey, this is my x-intercept and also my y-intercept, and label each one of those points. Then also, remember using that function notation that I can look on my graph and find some different values on there. So for instance, in this case, it says, hey, at 3, when my x value, my input is 3, what is my output? Well, if I look over on my graph at 3, 1, 2, 3, and look up, there's a point there at 3, 3. So my output there is at 3. And we can see that on the graph. And then also, remember this function notation, if my output, in other words, my y value is 2, well then what are my x values for that? So if my y value, my output is 2, let's look and see. Oh look, there are 2 different values for my x here. My x is -2, but there's also an input there at 2 that gives me an output of 2. So my x could be either -2 or 2 when my output is 2. So this is our absolute value parent function. Thanks for watching.